சார் ரெக்கார்ட்
Yes, sir. Yes, sir.
Yes.
ஸ்டார்ட் பண்ணலாங்களா சார்?
Yes, madam.
Yes, ma'am.
யசஸ்வினி மேடம்.
Yes, ma'am. Okay, ma'am. Okay, ma'am. Start the program. A pleasant and happy welcome to each one of you. Today is a special day because we come together for generic talk series titled Achieving Sustainability at Scale Leveraging Net Zero Cloud for Greener Future. I, Yashashwini, Assistant Professor from CSE Department, R.M.D Engineering College, he's here for the welcome address. A fervent welcome to our admirable principal, sir, Dr. N. Anbuchelian. We are fortunate to have his expertise, insights to provide with values and knowledge. Sir, your guidance is always lighthouse, the guides us in the right direction. With a special mention, I would like to welcome our dearest Dean, Dr. K.K. Tyagarajan, sir. A heartfelt welcome to our head of the department, Dr. P. Elumalai, sir, whose experience and dedication shape the academic direction of our department. Your vision is instrumental in shaping the minds of our students, and we are grateful for committed support in organizing this event. I rendered my heartfelt welcome to our faculty members. Each one of you play an important role in tuning the minds of our future leaders. It is the right time for me to invite our industrial resource person, Dr.Donald Patris. He completed his ME in Computer Science at R.M.D Engineering College. He is also an Anna University rank holder. He completed his doctoral degree in Computer Science from Hindustan University. Currently, he is working as a digital solution architect, senior advisor at NTT DATA, Chennai. From April 2019 to 2023, he worked as senior software engineer at Tech Mahindra Limited in Chennai. And also he worked as a team leader at Newgen Software Technology from June 2014 to March 2019. To mention a few of his achievements, he is a Salesforce certified professional with multiple credentials and recognized for excellence in global project and implementation. He successfully implemented a software tool in National Aerospace Laboratory at Bangalore. He also has multiple research publications as his credit. Now I request our chief guest to take over the session. Sir, please.
Thank you, ma'am. Thank you, team, for giving this wonderful opportunity. Thank you, Elumalai, sir, for giving this opportunity to share my knowledge with the college students as well as the research scholars. So let me quickly share my screen and start the session. Let me know if you can able to see my screen, ma'am.
Yes, sir. Yes, sir. Like we are waiting to see your screen, sir. We can see your video.
Okay.
Uploading.
Yeah. Now it's visible, sir.
Okay. So this is an interesting session because I have personally implemented this project for multiple customers. Okay. So this domain, this sustainability domain itself is a vast area. So many of the students or even the industrial professions are not aware of this technology as well as what in industry they are doing with sustainability. Okay. So the the major achievement for this sustainability is for every organization, they have to achieve the net zero for their organization. So it's one of the industrial standard which they need to achieve. So today in this topic, what I'll do is what you will learn from this topic. So why we need a sustainability report for a particular organization or a particular, even for a educational institute, we need some sustainability report for which we need to submit this to the government organization for us to get some credit, as well as the organization has to be registered from the government to get this certified as part of the government norms. And there are a lot of you might have learned in your environmental science as well as from your uh, other subjects, where you have seen what all the greenhouse gas emissions and how it affect our environment. So in detail, there are a lot of calculations, there are a lot of metrics which we will calculate this, how much the gas emission, greenhouse gas emission from a particular organization for a company. So I will tell you in detail how this emission calculation that are being captured in a particular organization. And there are some industrial standards that are available. So for example, in electricity, for a to produce a 5 kilowatt of electricity, right, what is the emission that has been occurred. So these kind of metrics that will be captured in some of the organization which they capture these data sets, and these data sets are readily available, so that we can able to calculate what is the emission that we are consuming. Okay. And then there are like multiple software platforms are available. So in this session, I will show you one net zero cloud platform which will help the industrial organizations like manufacturing or any industry to capture all this information, and they can able to generate the report, and this report can be submitted to the government for their approval process. And there are a lot of research area and ideas that are available in this sustainability environment, which I will also show you some of the research ideas which you can think through it, and which we can able to implement as part of our educational curriculum. Okay. So why it is important? So basically, this is one of the report which I captured from US. So basically, they are saying like in 2026 they need to submit the financial year report for what is a greenhouse gas emission they have done for their particular company. So there are so what every organization will do is each organization will have a sustainability team where there are experts in environmental science, where they will analyze the data, they will create the report, and it is very tedious process. So they generally we see some of the organizations, right? So it will take for them to months to calculate these emissions and generate the report, and there will be some lot of manual calculation they have to do, what is the emission they have done, and what all the renewable energy they could able to produce. Like for example, they have planted 100 trees around the manufacturing plant, and they are producing this much of emissions for the particular manufacturing. And with that they could able to get some credit point, like so for example, they have produced some electricity within some solar panels, etc. So that would give some credit points for them to calculate, and they have produced some these metric tons of greenhouse gases. And basically what we will do is we will subtract the what is a um, allocation they have done for the society, like the what is a carbon emission they have saved for the society, to the emission what they have done for the environment. So these are the metrics which they have to calculate as part of carbon emission metrics. So this is the report says, like for each and every government, like for example in US generally by June or July they have to submit the emission report for the previous year. What is for each manufacturing company, for them to run, they have to submit this report. And it is very strict in Europe, as well as we seen lot of in Australia. There are a lot of customers we have seen, the customers, the manufacturing plant itself getting rejected if this emission report is incorrect, or it is not up to the mark for the particular organization. So and some interesting factors which I wanted to tell, this is recently I traveled to Bangalore. So even like whenever you see any airline tickets, or if you see if they book a hotel or if they book a cab for you from your organization, generally you might have noticed that there is total greenhouse gas emission they will they will be providing as part of this. For example, here, right, the to and fro ticket as well as the cab service, they will say like 122 kg of CO2 emission per person. So this is an overall carbon credit for a particular person. So basically, why I am trying to show you this is each and every so for example, for this particular travel, we have like 61 kg of CO2 emission per person. So these are the metrics that are available in each and every, like all the airline tickets. If you go and see Indigo, Air India, Emirates, whatever the airlines you see, there is a column which you will see that there will be a greenhouse gas emission what you have consumed for this travel. Okay, so the reason why I am stating you this is for a particular, for an organization to capture these metrics, right? For each and every person who is traveling, for example, I'm traveling for a conference for my company from here to Bangalore. So my company will book a ticket, and this ticket, the carbon emission data will be captured in my company record, so that it has to be submitted to the government organization. So this is one of the key thing which we need to identify. So basically, when we see like in order to capture this emission, so these are some before we understand sustainability, we need to understand what are the different types of gas emission that are being uh, monitored or captured. So there are like in industry, this is a broader industrial standard. Like this is standard for across the globe. This is standard. So in this, we have a scope one emission. So scope one emission or nothing, but you can able to relate it to your company facilities, like your manufacturing, like you have a seven-floor building which has these many square feet of areas, and you have these many refrigerators in your particular um organization, and these many air cooler you have in your organization, and you have number of vehicles for your particular organization. So all the CO2 emissions that are being directly impact for a particular organization, you have to that will come under scope 1 emission. Okay, so even you can think about your college as campus as well. The electricity bill which you are paying for your college campus, the number of vehicles you have in your colleges. So what are the fuel consumption of these vehicles, and what is the impact it is doing for the sustainability. So all these metrics has to be captured for us to which will go into scope 1 emission. Okay, and then we have scope 2 indirect scope to indirect. So basically, scope to indirect is the electricity which you are. So these are the metrics like which you can, like the electricity bill which you have consumed, and the number of vehicles, uh, the fuel what you are applying for your vehicles. So those things you can able to capture, and these things can be captured within your organization itself. But there are some parts like electricity or purchased electricity. So for example, you have used 100 kilowatt of electricity in this particular month. So it will for us, for that electricity to be produced, either it can be purchased from the government, or it can be generated by your own solar energy wind panel. So in that electricity, what you can able to see is whatever the electricity you have purchased, so there is some set of industrial standards that are available, like to produce this much of electricity, there will be these 100 metric tons of CO2 emission that have been done. So that kind of metrics, maybe I will show you in a demo, like in a real-time application. There is a government website which is available. So I'll show you like for each and every region specific, like we have 4 thermal power plants, we have 2 nuclear power plants. So based on the metrics, each and every city, how it is consuming the electricity, there is some set of carbon emission that would be captured. Okay. So what we have seen is some of the rural areas where they are majorly the electricity is being produced in the windmill. So there the carbon emission is very lesser compared to the electricity that are being produced in the cities. So for example, if we consume the electricity in R.M.D engineering college, the electricity can be maybe purchased from the Tamil Nadu government. So that directly it can come from like North Chennai thermal power station, where they have thermal power plant. There will be lot of carbon emissions that can be occurred. So that kind of emission factors will come into picture in scope 2 emissions. Okay. So scope 2 emissions are like the purchased electricity, the steam, heating and cooling of their own use. So these kind of metrics that needs to be captured in scope 2 indirect emission capture. And there are scope 3 metrics where you have, so for example, like the air ticket which I have showed. Okay, so I don't have that. It's purely depend on each and every aircraft industry or each and every transport industry, what fuel they are using and how much what is carbon emission that particular company is doing. Okay, so those kind of emissions which are not directly owned by the organization, but we need to depend on multiple other organization as well. So the aircraft, the carriers, where they will say like these many carbon emissions you have produced by your travel. So these kind of emission will come under scope 3 emissions. And you are transporting some goods. For example, think about a manufacturing industry. They are transporting the goods from one place to another place, where they are hiring a vehicle from a different company. So when they provide the invoice or the bill to the particular company, they have to provide the what is the mode of transport, how much emission they have done. So all that has to be captured, and the industry has to make that data into their system for them to calculate the overall CO2 emission they have done from the particular organization. Okay, so those those values which are not related directly to the organization, like the business travel, the goods travel, or whatever the transportation or the waste management. So all these things will come under scope 3 emission. And even in scope 3 emission, we have some of the indirect assets as well. So for example, if you are uh, instead of having your own building, you are trying to accommodate a building, for example, in a SIPCOT, you are accommodating your office in a SIPCOT as a one floor means, so there will be some COT metrics across the SIPCOT area itself. So where we need to say, so for that particular uh, uh, building, or what is the emission there, what is the electricity source of power they are providing for that particular asset. So those things will be captured in scope 3 emission. Okay, so now you got a broader idea like what are the different types of emissions that are being mapped, and this is a global standard. You need not to worry about like what if this is here different in India, this could be different in US or Australia. So this is a global standard which they have streamlined across the globe. Okay, so once you identify all these scope areas, then you need to capture this data from your particular organization. So that's a very difficult process, I would say. It's not very easy to capture, like not from a single system you can directly take all this data and you can create a report and send it to the government. Not like that. Each and every travel you have to, for example, you are sending a employee to a business appointment, like for a business meeting for a particular, so here the organization has to capture the emissions, whatever they have that are being invoiced from the air travel, and whatever cabs he has taken for the travels. So all the things has to be captured. And even if it is a manufacturing plant, right, they have to capture what is the emission. Like there are a lot of IoT devices will be there, and there will be a lot of metrics they have to calculate. And from that metrics they need to calculate all the data whatever that are being received from the particular industry. What is the number of emissions, what is the electricity power they have consumed for this month. Each and every data it has to be captured. So let me move on to the next slide. So for this, what we need, actually, we need a complete customer relationship management software. Okay. So what this software, the requirement of a CRM software is, it has to collect the data from multiple systems. Like it has to collect the data from your um uh, manufacturing plant. It has to collect information from the each and every employee for his business travel, whatever he is contributing for the CO2 emissions. So all the data needs to be captured. And also we need to capture the you might have different branches in different locations. So each branch data has to be captured, and whatever the electricity consumed has to be captured. And there will be um, each will have a different units, I would say. So electricity will be in generally kilowatt, megawatt, or how much electricity you are being used. And for example, in fuel means you are using 100 liters of diesel, 100 liters of petrol. So these fuel metrics you will have in liters, and the CO2 emission gas would be in metric tons. So basically all this has to be generalized, and there are some calculations which I will show in the real-time demo, how these calculations that are being made manual, and how the CRM system could able to automate all this activity. So some of the organizations, when we try to implement this sustainability software, right, what we have seen is they will have like 10 to 15 people who are completely working on the sustainability. There will be some sustainability consultant from each branch. They will collect the data, they will do the audit. It's a tedious process, we would say. And if there is any problem occurred, if they miss any data, if they miss any calculation, the entire process may go wrong. So we need a software which can calculate all these metrics and which can give a standard report. So that's a need of a CRM systems which we require. Okay, so this is one of the high level data functional architecture, I would say. So there are, like as I mentioned you, the energy, whatever the energy they are being used, like the carbon emission, the electricity power what they have consumed, and what is the carbon emission they have done, and what is the waste that are being produced from the particular organization, and how many buildings or assets for the particular organization has, and what is the energy usage of these particular buildings, and how many people are traveling either day-to-day cab service or even for a business travel also. And also in industry it's very difficult. For example, right, there are multiple supplier information as well. So if you are generating a solar wind panel, okay, for example, that's a company, so which is generating a solar wind panel, they might get some particles, or they get some raw material from a different supplier who will manufacture the silicon plate for them, and they would transfer it. So for a particular organization, when they submit the report to the government, right, when they submit the report, they need to say even the supplier who has supplied this particular component for them, they have produced with less carbon emission, they have done with this many number of carbon emission metrics, they have shared this data, right? So it's very, they might have hundreds of suppliers. So our system should capture all the supplier information data as well. Okay, so and also there are some, as I mentioned you, there are some standard conversion rules that are available. So they have made some metrics which needs to be captured, so that like scope 1, scope 2, and scope 3 emissions that are being there are some different standards or data sets that are available which will help them to standardize it. So for example, I will show you a live demo on e-grid platform from the government, where they have released, and I would show you like what is a electricity usage for a particular region, how much carbon emission it would cause. So those kind of metrics will be shared from the particular organization, and even they will share you the calculation of it as well. So that data set will always have some calculation which can be utilized for the CO2 emissions calculation. Okay, so there are like different metrics for travel. We use the USEIO. There are some travel data sets that are available, which I'll show you some of the data set as well as part of this session. And then using all this data, whatever that are being captured from the assets what you have what the industry has, and using some of these data sets as well as some scope calculation what we have, we need to create a report like we need to create a report that can be shared to the government for us to get the approval. Okay, and there are like standard carbon footprint, and with this data, what are the benefits what we can do is like we can able to, once we receive the data, for example, once I receive the data for past 6 years, this is a carbon emission my industry, my manufacturing plant has done. What is a future goal? In what time we will achieve zero carbon emission from our company? So that's a generally that's a target. Even if you whatever manufacturing industry, if you see, if you go and see their website, what you will see is their target for sustainability for zero carbon emission. Most of the industry they would say 2030. Some industry I have seen it would be 2050, where they will say our industry will produce zero carbon emission for the manufacturing. So that means that they would get the energy from renewable resources, solar energy. They would get wind energy without affecting the environment. Okay, and with this data, with this calculation, the CRM system should able to do a climate. They should bring a dashboard each year how much we have produced and what is the what is the metrics we could able to reduce. So all these activities we could able to we should able to generate a dashboard, and we can able to build some scientific analysis. We can build some we can run some AI tools on top of it. We can bring some prediction, and so these all the things a software tool has to process. Okay, so for this, what these are the general functional feature the what the CRM system should have. Okay, and for this to build this CRM system, generally the key features, these are the key features that tool should have, right? So it will have a single source of truth. I already explained you the data that are being consumed from multiple systems, multiple sources, that has to be captured in a single source of truth. And the energy consumption management, how this energy is being captured, and each year on year, month on year, all the things has to be captured in a single system. And you not only energy, the waste management, the water management, all this should come as part of this ESG data calculation. And we need to create a sustainability dashboard, and how these data that are being collected, and whether we have done proper auditing for this data. So all the things has to be captured in this particular system. And also the supplier engagement, right? So if there is any third party company that are providing some, for example, we are purchasing some raw materials from a different company, so that company data, how much emission they are calculating, so those data has to be also captured in our CRM system. So basically we have to our system should be capable of integrating with the different customer portal to collect this data, or we need to import those data from the even from the supplier or from third party companies as well. Our system should be portable. It should be integrated to their system as well. And then our system should have some analytical tool where it has to build some run AI. It has to give some prediction. It has to bring some dashboards. So all that feature has those are the key features I would say this a net zero software should have. And also it has to plan for the future, science based metrics, and what is our future goals. It has to help the organization to uh, make a future plan. So all the predictions that to run the AI metrics, all the things has this. So this software has to do. Okay, I will show you a real time demo of a real net zero software. What are the things it can bring in, and how it can impact the particular organization as well. Okay, and so this architecture you would see like, so a high level what I mentioned to you in the previous section. So whoever the CEO, the HR team. So basically, the CEO has to have a complete view on the reporting. What is the sustainability goal, and how we are achieving it, and how many travels we are making. what is the emission our manufacturing plant is doing. So all the things our CEO or the high level management team will have. And HR and finance team, what is their purpose? Basically, they would capture all the invoices. So for example, the ticket information which I showed you, right? So it has the CO2 emission data. So the HR team, the finance team, they would capture the uh, uh, particular carbon emission. So those data has to be fed into our system. And also from sales and marketing team, where they have a different set of marketing team, and what is their travel, and what is their impact to the CO2 emission. And they would have the corporate team. They would each and every employee, they would see a different set of like what is their emission. Like for example, this software should show them like what is a electricity usage for the particular plant, or what is electricity usage for the particular department. So those things has to be they need to know as part of this sustainability software. And also if there is any R&D or manufacturing plant which they can able to, which they also have some responsibility to see all this activity and how much emission they are making it. And there are multiple shareholders, or there are like uh, from the external party. Like when we do the audit, there will be some stakeholders from the government organization, there will be stakeholders from the regulatory board. So all those people have to see all this critical data from a particular company. Okay, so what are the data which we have? As I mentioned you, the scope 1, scope 2, scope 3 emission, the what is the energy management the company is doing, what is the water management, waste management, and what all the social activity they are doing. Okay, and how they are bringing in to reduce power consumption, or to bringing in some of the actionable insights. And how the software is able to do the auditing and governance, and the policies. So all those things has to be integrated into a platform which will get the data from downstream systems. So basically, to in order to capture all this data, right, it is not necessary, not from a single system they can able to capture. So there are like multiple downstream systems will be available. Like there will be a sustainability database where they will capture the electricity metrics, what is the power consumption, and there will be, as I mentioned you, there will be an HR platform which they will keep track of all your invoice details, the ticketing information, whatever the CO2 emissions you are doing from the employee perspective. And from finance perspective, the finance data would certainly have the invoice details from a third party vendor who are giving some invoices, and the finance team purchase some application from a different company, what is the emission they have captured. So all those things will be captured as part of the finance team. And there are corporate facilities, corporate facility in the sense, we have a 7th floor building in Chennai which is producing this much of electricity. So what is a uh, what is a emission, or what is a metrics that needs to be captured to calculate this CO2 emission. And there will be some ERP applications generally for manufacturing plants, right? And how many what is a, manufacturing quantity they have produced. So for example, to produce one battery, they might have used 20 grams of CO2 emission. So if they produced 100 products in a particular month, what is the overall CO2 emissions? Okay, so those things will come from their ERP system, from a manufacturing plant. And if it is an IoT platform, so for example, you are having a ship that transfers the goods from Chennai to UK. So what is how much kilometers it has traveled, and how much time it has waited in a particular port, and how much emission it has done. So all those things will be captured from some of the IoT sensor devices from the particular devices. And there are some third party applications as well which needs to be integrated. So uh, now, in order to capture the simple scope 1, scope 2, scope 3 data, the software should connect with multiple applications, and also it has to run seamlessly as a single point of truth, so that it's not creating any wrong data, or and it should be accurate as well. Okay, So let me go to the next slide. And there are different data model that are available. Okay, I will show you in real time. Okay, so majorly this is one of the data set, the data architecture which we have created. So in order to capture these emission factors, right, there are multiple emission factors. So let me try to zoom it up. So basically what we generally we do is for a particular account, for example, R.M.D engineering college. Okay, there is a group of institution, we have RMK institute. So each it will have a single account. Okay, so each account will have a uh, multiple stationary assets. Okay, so asset in the sense like RMD has I'm just giving an example. RMD has different buildings. For example, it has 10 different buildings in the college campus. So each and every building, what is the square feet of the each and every building, and what is electricity consumption. So all those asset information has to be captured and mapped under R&D engineering college. The same way R.M.D engineering college having 200 vehicles for the employees, for the staffs, as well as for the students. Each and every vehicle details has to be captured and how it has been mapped. So this is generally a one-to-many mapping. You might have read in the data mapping in the database, right? So similar way, we would initially, in order to implement a complete sustainability for our organization, what we will do is we will create a overall architecture how this data has to be captured, so that the data model which should be uh, expandable in future, so that like if there are any future asset we are adding in future, it should be in one to many model. In that case, we will not have a single asset, we will have multiple asset as well. So there are multiple other components like we would say that would be mapped to this particular stationary asset object. Like there will be multiple water footprint. We need to map how much water consumption this building is doing, and we need to capture the electricity for this particular what is a carbon footprint for this particular uh, application. So generally it will come under scope 3. What is a electricity emission that are being captured. Let me just show you some like uh, from each and every employee perspective, right? What is the like as I told you in the ticketing information, what is the CO2 emissions that are being each and every travels that are being made, the air travels, the hotel stay, it is a ground travel, if it is a rented car, and if it is a refrigerator emission, for example, how much a simple refrigerator, or how much AC you are using. So generally the science behind is for a for example, you might have using some centralized AC in your across your college campus. Then whenever the AC runs, right, so there will be some chemicals which will be the gas which will be there in the particular refrigerator coolant device, which will keep on which will keep on producing the uh, cooling factor. The same way, it would there will be some kind of emissions that would cause, that will have some destruction to the environment. So those kind of metrics I will show you in real time. What are the metrics we try to capture? Like there is methyl, there will be chloride, there will be some kind of refrigerator metrics also available in the market. I will show you that as well. And there is a carbon emission factor. How much carbon your electricity emission factor, how much you are using for the particular asset. So these are some of those mapping which has to be made in that in this particular stationary asset information. So we will design a data model first thing, so that our organization, once we wanted to implement a particular sustainability platform for a particular organization, the first thing we will understand, let me go to the previous slide. First thing we will understand what are the downstream systems that needs to capture all this data, and how this data will come into this particular platform. And then we will decide what is a data model that we have to design for a sustainability to capture all this information. Then the third part, I would give you a real-time example now. Okay, so it would be boring for you to continuously listen to the conversation. So I will show you some real-time demo, real-time application which we have developed. So in a manufacturing company, right? So this is an user journey generally. Okay, I'll try to quickly explain you what is a user journey that we have. So first thing we have to do the emission capture, like emission capture in the sense we have to capture the emission factors, right? There are some industrial standard emission factors which I will show you now. How these emission factors would come in and how this can be utilized to calculate the scope 1, scope 2 and scope 3 emissions. Okay, there are some certain set of data sets which are available. Uh, Let me quickly go back to the other screen. Okay, so okay, so there are a set of let me just go back here. Okay, so this is one of the government for a US e-grid data. Okay, so in US we have different regions. Okay, so for each region they have this is their electricity board. So when we for example when we have a plant in uh, northeast, or when we have a plant in any region, right, northeast in US, when we select that particular area, and what based on the fuel consumption per megawatt of electricity, what is the CO2 emission? Okay, what is the SO2 emission? What is the NOx? So these are different metrics which they will share you from each and every region specific. Okay, so for example, I have 10 different plants in this northwest region. So what is the electricity that are being I am consuming for this particular place? And so they have a different metrics. Like for example, here if you see the electricity is being produced from gas is 24%, from coal charcoal 16%. They have a nuclear power plant 3.1, from hydroelectricity, from water electricity they are producing 38%, from wind 11%, from solar 3%, from other geofoil fuels 3%. So based on this metrics we could able to calculate for each and every region specific. There will be a metrics for to calculate the CO2 emissions. Okay, so these data are readily available. So what generally we will do is, in our software, right, we will import all this data. So there are some standard set of data sets that are available. So what we will do is, let me just to show you some example. um, so this is some of the air travel data from UK Airlines. Okay, so generally what we will do is we will import all this data into our CRM platform, so that the passengers, what is a passenger per passenger, what is the electricity per kilometer, what is the electricity, okay, what is the electricity that are being consumed for per passenger. Okay, so what is the CO2 emissions that are being captured for a particular passenger, if it is a economic class, business class, and if it is an international travel, and these are the metrics. So these are the CO2 emissions per unit. Our system would capture, and it would be used for the calculation. Maybe I'll quickly show you this example. So okay, let me go back to the slide. So these are the carbon emission data which the system needs to capture in order to calculate these CO2 emissions, etc. Okay, and these data will be imported into our software, and then we will capture the electricity emissions. Okay, let me just quickly show you some electricity emissions. Okay. Mm. Okay, so for example, I created a sample record called manufacturing company. Okay, so this is how the data in the system would look like. For the demo purpose, I created a sample data. So what I have done is, for this particular asset information, we have some different set of energy usage. So for my manufacturing company, right, for example, I own a company. So this company, we have a building. So for this building we have a some monthly electricity bill. So each record will be automatically captured from the system, and this system, for example, right, so it will have the electricity bill, when is the start date, when is the end date, and what is the electricity consumption. Like for example, right? Let me just quickly show you. So for this energy consumption, so we have consumed 1,000 kilowatt of electricity this month. Okay. So what the system will automatically do is, so this 1,000 will come from the electricity integrated system, which will capture this electricity information for per month, and then automatically this calculation will be done. What is basically what the electricity would come under scope 2 emission, which we are purchasing from a third party, from a government organization. So this 0.3546, this data would be automatically calculated, and it would be stored, and this would be available from the global report. Okay. So in order to further drill down for your understanding, right, I created a slide on how this would be captured. Let me just quickly go to that. Yes. So this is the first which I showed you now, right? There is a company data which we have captured in the CRM system, and what is the total number of floors and total number of buildings we have. And then we have captured the monthly electricity bill, refrigerator and fuel bill. Let me go in deep to the monthly, like we have captured 1,000 kilowatt of electricity. Let me quickly go to that particular 1,000 kilowatt of electricity, how this calculation that are being made. Before implementing this software, a sustainability auditor, he would do the manual calculation. So for example, for this 1,000, they would calculate into in order to like there's the standard unit to capture the CO2 emission is like TCO2 underscore E, where it is mentioned as the total metric ton of CO2 emissions that are being captured. Okay. So here the conversion factor, so this is a standard conversion factor. So as I mentioned you earlier, the CRM software has to create a generalized value. Like this is for the electricity conversion, which they have converted using there is a emission factor which needs to be multiplied 354.602, that is per gram per kilo gram per kilowatt. What is a CO? So in order to capture this, they have, this is a factor which we have got from the government organization, which I showed you earlier, right? So there is different government. Let me just quickly go back. Okay. So for each and every electricity grid, right? So there will be some 631.7 uh, uh, CO2 emission. So for each, and based on the region specific, what our software will do is it will automatically take the value from the region specific, then it would do the calculation. So for example, for this particular region, right, it is taking 354. It has to be multiplied with number of units we have utilized, and there will be a generalized metrics which we are dividing to in order to get the point value for the overall electricity emission. So in this way, we are capturing the CO2 electricity emission. Okay, let me go back to the software and I'll show you. So this way we are capturing the CO2 emission. So our software would automatically calculate this value, and it would be available for the global report. Okay, and similar way, let me go back to the manufacturer. There are like other electricity, other CO2 consumption factors like refrigerant or monthly fuel. Let me go back. Let me go back to this presentation, and let me, so for example, right, we have some monthly fuel. We have consumed a fuel of about 1,000 liters of diesel we have consumed for this electricity consumption. So based on this, what is a calculation we have to bring in as part of CO2 emission? It would come under scope 1 emission, because directly we are using this CO2 data. Okay. Um, Let me just quickly go back. So for this 1,000 liters of diesel usage, what is my fuel consumption? So there are some generalized formula which we will use, right? So for this, there is a separate conversional unit which we have some diesel. So basically, they are similar to the electricity board. We have some factors for diesel emission factors as well, which the system would automatically take. There is a standard uh, governance unit who have transferred for this diesel usage, what is the CO2 emissions they are bringing into our society. So those calculation would be automatically made based on the emission factors for diesel or petrol. We have what we have captured as part of the emission factor. It will calculate and it is bringing the value 2.67 of CO2 emission it is causing for the particular company. Okay. So similar way, when you go back to the refrigerant, right, we are using some ACs or some manufacturing chemical products, which is we are using like 10 kg of refrigerant gases we are using means. So what is the fuel in kgs we have captured. Okay, the system each and every month you are capturing how much refrigerant gases, methyl chloride, what you are using as part of our emission. Okay, so for example, consider this as a manufacturing company. They are using this they are using this methyl chloride as a emission factor from a particular coolant system. So how much they have consumed and how much the carbon emission that it has to be captured. So all those things will be captured with the general government recognized it's a data set. With that data set, it will do the calculation in the backend, and basically these things the user need not to do it manually. It will automatically calculate all this data. Okay, so it's for the refrigerant data we will capture. And then for the freight and for example, when you are traveling through employee travel, how it is being captured. I showed you the ticket and what is the CO2 emission, right? So automatically we can give some distance like the 2000 kilometers the employee has traveled, and what is the carbon emission he has made to the industry. So all those calculations will be made through the emissions factors. There are like I showed you in the Excel, right? What is emission factor if an employee is being traveled in economic class to UK? What is the emission factor for a particular aircraft industry? So all the things will be captured, and we will calculate the CO2 emission based on those activities. Okay, so let me just quickly go back to the presentation. So these are all the metrics which we will capture, and we will capture the CO2 emission for the uh, travel. In terms of travel, we would have captured this. And then there is these many tons of waste disposal we have made, and we have made some metric tons of waste disposal. And what is a disposal type? We have disposed some metric tons of recycled waste, which we have if we have mentioned that as recycled in the sense like, for example, if it is an agricultural waste which can be recycled and which can be used from our environment, so those type of they have to mention it as recycled. So automatically this 1.98 metric this CO2 emissions what we have captured will be added to our credit score value, so that when we show this report to the government organization, so we can say that we have disposed these many tons of agricultural waste, and we have done some recycling of this waste into some other source of biochemical biogas preparation, or we have done some fertilizers using this chemical waste. So those kind of recycle activities can be also be captured, which will be acted as an credit score for a particular organization. Okay, so and I showed you there are like business travels which we will capture for a particular manufacturing company. If they are traveling through UK, and how much kilometers they have traveled, and based on this the metrics which I showed you, right, uh, um, in the Excel which I showed you, each and every for example, if it's in UK, if it is an economic class travel, what is the metrics we need to capture, and how it has to calculate the CO2 emissions. So those things of data will be automatically captured based on the data sets what we have for the travel emission perspective. Okay. And similar way, we have some travel for Microsoft conference. A employee has traveled from one location to another location. What is the trip cost? He has acquired some taxi, and what is that emission that taxi as the based on the vendor bill, it will automatically capture the CO2 emission for the taxi travel from the ground travel perspective. Okay, and similar way, if the employee is staying in the hotel, what is a hotel stay travel? So those things will be captured in the hotel stay metrics. Okay, so those are the CO2 emissions which will be captured from the software from the hotel stay metrics as well. And based on this, the outcome of this is, for example, what is the emission we have done in this 2021, and what would be our forecast, and what would be what all the reduction techniques which we need to do. So these kind of advanced reporting capability our software should able to provide based on some existing historical data as well as some futuristical data through some AI predictive learning. We would capture all this data and we will bring some predictive analysis to a particular organization. This is some of the sample report which you have generated for the real-time customer, and also uh, we have captured some like how the what is their future company goal and what they have brought in and what is a commitment for the particular organization. So those things will be taken care by our net zero software. Okay, and the so like this is one of the company which we have implemented, and once we done the reporting, we will create a scorecard, and this scorecard would be valid and it would be auditable for the organizations or even from the government firms. They can able to audit this particular data as well. And then so these are some of the carbon credits which we have achieved through this like the as I showed you, there are some renewable energy which will be captured as part of our software and which will be added as a carbon credit for the particular organization. And then we will capture some lot of emission reports, how in each and every region what is the carbon emission this particular company is doing, and we will create a holistic report for a particular organization. Okay, and so in order to implement this software, like we need to understand what are the requirements from the company and how to build this, what are the data sets we need to bring in and how we can able to implement it. So all those things we could able to clearly articulate and we could able to implement for a particular company. Okay, so identifying the emission factor and how to get this data, how to load it, how to calculate the carbon emission, and how to create the report. So these are the step-by-step activity which we will do, and basically this would continuously bring the efficiency for our organization, and it will bring some auditable and it will bring some transparent to the shareholders, to the stakeholders, whoever that are available. They can able to see the what is the emission we have made and what is the sustainability goal our company has. Each and every manufacturing company, if you go to their website, there will be a sustainability page where they have to tell what is the emission they are doing for the organization and what is the emission they are bringing, what are the factors they are helping for them to bringing down. Okay, so those things will be captured, and the so you now you got the complete understanding like what is the sustainability and how what the software can help in the sustainability, and what's based on the software data, how you can able to manipulate it and how you can able to share the report to the particular company. So those things you might have got some broader idea, and there are a lot of research ideas which you can take as part of it, like the predictive algorithm which you can build for sustainability, which can help them in the future. So those kind of add-on components which you can build on top of sustainability and for the future goals as well. Okay, so you got some better understanding on the sustainability platform, yeah, how the industries are using it, and if there is any questions or if there is any research ideas, I'm happy to help you, team.
Thank you, sir. Thank you, Dr. Donald Joe Patris, sir.
Thank you.
Now it's time for vote of thanks. With a great pleasure, I'd like to thank our persons and our resource person, Dr. Donald Joe Patris. So sustainability is no longer about doing less harm. It's about doing more good at a greater scale. The future depends on what we do today and how boldly we choose to do it together. Small actions create change but scaled actions transforms the world. Sustainability begins with awareness, but it succeeds through collective action. We are not just inheriting the planet, we are shaping its future. Growth and sustainability are not opposites, they are partners in progress. And let this be our shared commitment to think bigger, act faster, and work together to create systems that not only sustain us but allow future generations also to thrive. I thank our resource person, Dr. Donald Jose Patris, our HOD sir, Dr. P. Elimalai, our principal sir, our dean sir, and all who have joined hands in making this event a great success. Thank you, sir. Thank you, one and all.
Thank you, madam.
Thank
Thank you,
you.
Donald.
Thank you, Alumni sir. Thank you, team.
Thank you for your questions.
Thanks.
Thank you all. Thank you all.